Okay, we have to finish question 2. We're up to the last part, 2H. All right, we're taking the limit as x goes to infinity of minus 6x to the fourth minus 3x plus 1 over 3x to the fourth minus 2x squared plus 1. So again, when we take the limit as x goes to either infinity or minus infinity, we only have to take into consideration what we call the leading terms, the terms with the largest powers. All right, so that would be these two in the numerator and denominator. Okay, so that would be equal to the limit as x goes to infinity of minus 6x to the fourth divided by 3x to the fourth. All right, so that's these x to the fourths cancel, and we just have minus 6 over 3, which is minus 2. Okay, let's continue with number 3. We're going to take some derivatives. Okay, so let's start with part A, actually. Y equals 3 x to the fifth times the cubed root of 5 minus x squared. So here we have a product. We're going to do the product rule. Here's one. We can consider this to be f, and this is the other part g. All right, so y prime is equal to the first function, that's 3x to the fifth, times the derivative of the second. All right, for the second, for this part, we're going to do, let me write this a little better. Okay, we're going to do a chain rule. The outer function is this exponent 1/3. Cube root is equivalent to exponent 1/3. So we're going to bring down the 1/3, change the exponent to 1/3 minus 3/3, which is minus 2/3. And we'll just copy over the inner function as is, then multiplied by the derivative of this inner function, that's minus 2x. Okay, so that's a chain rule, and all of this represents the derivative of this second function here. Okay, plus the derivative of 3x to the fifth, okay, that's 15x to the fourth, times the second function. Okay, let's see what do we have in part B. We have a quotient, y equal x cubed divided by x squared minus 7 to the 10th. Okay, so let's take the derivative. Y prime is equal to, we're going to use the quotient rule over here. So we first square the denominator, so that exponent will become a 20 here. X squared minus 7 to the 10 squared is x squared minus 7 to the 20. And let's take this denominator and put it on top. X squared minus 7 to the 10 times the derivative of the numerator times the derivative of x cubed, that's 3x squared, minus the derivative of this denominator. Now we have a chain rule, 10 x squared minus 7 to the 9 times the derivative of the inner function times 2x. Okay. So you can see we have y equal sine 3x to the 10. Okay, so we have an outer function that's exponential with exponent 10, inner function sine of 3x. Okay, y prime is equal to derivative of the outer, 10. Okay, and just copy over the inner function as is. Sorry, that's just, let me get rid of this 1 second. Now let's multiply by the derivative of this inner function. We have a chain rule here as well. So the derivative of the outer, that's the derivative of sine, is cosine. Here's the inner. Times the derivative of the inner 3x, that's times 3. Okay, here we have, in part D, we have a function that's defined implicitly. In other words, it's not solved for y. So we do implicit differentiation. (2x squared minus 3y squared plus 5xy equals 10). Alright, term by term, derivative is 4x minus 6y y prime plus, and here we have a product rule, 5x y prime plus 5y is equal to 0. And we're going to solve for y prime like we usually do. We'll factor out the y prime from this term, and from this term, okay, so we factor out y prime from this term and this term, and then we have plus 4x, we have the plus 5y equals 0. Let's put these two terms on the other side of the equal sign. And finally, divide by whatever's multiplying y prime, by whatever's in the brackets here. Okay, and we have y prime is equal to this expression. This expression that contains x's and y's. Okay, and finally we have y, which is defined as a function of u, and u defined as a function of x. And we want to find y prime or dy dx. Okay, that's what we want to find, dy dx, not dy du. Okay, so this is sort of like the outer function, and this is the inner function. So we're going to do a chain rule over here, and we're going to write the chain rule in the following way. Dy dx is equal to dy du. That's the derivative of the outer times du dx. That's the derivative of the inner. Notice in this, with this notation, it appears as if the du's cancel and we get dy dx is equal to dy dx. So it's a nice notation. Anyway, let's just calculate what we have to. Dy du, that means taking this derivative in the usual way, quotient rule with respect to u. So we have u minus 3 squared. And here we have u minus 3 times 3 minus the derivative of the denominator 1 times the numerator 3u plus 2. Okay, so that's dy du, and now du dx is 2x. And that's it, we're essentially done. Okay, so this really is the derivative, and you could finish here, but if you want, you could substitute, instead of u, you could put back the x squared plus 5. So if you do that, we have u minus 3, that's x squared plus 5, subtract 3, that becomes x squared plus 2. And 3u plus 2, okay, so that's, I'll just plug in the x squared plus 5. That's 3 times x squared plus 5 plus 2. And here we have in the denominator u minus 3, again, that's x squared plus 5 minus 3, that's x squared plus 2. And that's squared. And then we have this 2x here on the right. Let's not forget about that. Okay, and that's it. And we're done. That's question 2E.